but I'm pretty sure we know what you're talking about.
Yeah, do you see the image right there?
Yeah.
Okay.
Yeah.
All right, so everybody here sees it too. All right, so how do we answer that? What does it want you to do? It wants you to fill up the percentages for the empirical rule, correct?
Mm-hmm.
Yeah.
What's the percentage? What's the percentage from x bar minus s to x bar plus s?
What did he say? From what?
For one standard deviation, what is it?
68%.
How about the next one for two standard deviations?
95%.
How about for three standard deviations?
99.7.
Yep. So far, so good. Yeah. No. This is the one that's posted on Teams. Now, how about this here? What would this guy be? The blue, like from here to here. What would that be?
34.
And the other side would be?
34.
Okay, so we agree with that. How about from here to here?
12.5. Oh, wait, no.
Thir-
It was
13.5, 13.5, and 13.5. And how about from the next tail, the next little piece? It's going to be what? 2.35.
Yeah.
Now remember, this is percent. All these are percent. All these are percent. Is that too difficult, guys?
No.
No,
That's
sir.
that's the actual first question.
Mister.
Yes.
But like, how would you get those percentages in the
You
on
just
the
have-
actual graph itself?
You just have to memorize it.
But okay, so that's like the base like
That is for
percentages.
any curve. That's normal.
Is he low for anybody?
Do you hear me?
Yeah, we're pretty low.
Oh, wow. I'm like, okay. Do you hear me now?
Yeah, okay. Actually, yeah. Yeah. I think it was just my mic.
Mister.
Whoa, what happened?
Okay, so that wasn't just me. Good. What happened, miss?
Is Mr. Alive?
Yeah.
It
No,
was
I
frozen.
yeah, something happened.
If he doesn't come back in 15 minutes, we can leave.
That's the rule, yeah.
That is unfortunate for him. Uh,
All right. So for what you have to remember is that for any normal curve, all you're worried about is how many standard deviations you're away from the mean. That's all you
Wait,
gotta worry
Mister.
about.
You just like completely blanked out for like a good minute.
Yeah.
Yeah, that's because
Let me
because
guess, school Wi-Fi.
my tablet got locked out. All right, so back to the question I was being asked. These percentages are all the same for normal distributions. As long as it's bell-shaped, all you gotta worry about is a standard deviation. That's all you gotta worry about. If it's one standard deviation away from the mean, you're gonna have 68% of data. It doesn't matter what curve we're talking about. Okay?
All right.
All right, so here's what I want to do now. I want to go ahead and do the next question. All right, the next question says, what is the formula for Chebyshev's theorem? What is it?
1 minus 1 over k to the squared.
1 minus 1 over k squared. What does k squared stand for? It stands for the amount of standard deviations we are away from our mean. Okay, that's what it stands for. Bender. Hey. I told you to Orthodox. I just told the officer, so just bring it down. Got it.
Got it?
No worries.
Everything good?
Yeah.
So, ladies and gentlemen, everybody good? Nice to see everybody.
All right, Bender.
See. Yeah.
So does everybody understand that? There's nothing to understand there. That's the formula. Okay? Yes. You can't see it? There's two things you can do. One thing is I can turn off the lights. Two things. Okay. So this one doesn't do it on a lamp. You see it now? Don't be shy, you can move it around. All right, let's do the next question. Because the next, I'm really not gonna do it, I'm gonna set it up for you. Okay? So, I'm gonna set it up for you guys, so you can do it. So here's gonna be the next question. So, I'm gonna paste the question there. It says, if a group of data has a mean of 60 and a standard deviation of 21.2, what is the interval that should contain at least 96% of the data? Would we use empirical rule or Chebychev's theorem? Is it normal?
Right?
Is this a normal distribution?
Would it be Chebyshev?
It has to be Chebyshev because you don't know the shape. Because you don't know the shape. So if you don't know the shape, then you have to figure out the 96%. You have to figure out when that happens. And it says at least, so we know it's Chebyshev's. We know it's Chebyshev's. So what you gotta know is that for k equals to 2, we have at least, how much was it? For 2? For k equals to 2, it was 75%. The way we figured that out is we went 1 minus 1 over 2 squared, which is 1 minus 1/4, which is 3/4, which is 0.75, 75%. Agreed? When we tried the next one for k equals to 3, it was at least what? 88.9%. Did we do k equals to 4? Did we do k equals to 4?
Mr. What?
Did we do k equals to 4 for Chebyshev's theorem?
I believe so.
Well, let's see. K equals to 4. That would be 1 minus 1 over 4 squared. That would be 1 minus 1 over 16. 1 can be rewritten as 16 over 16 minus 1 over 16. That comes out to 15 divided by 16. 15 divided by 16 is I believe.
It's gonna be like 0.93, I think,
0.9375, I think.
Zero
or something
point
like that.
five, yeah.
0.99375, which is 93.75%. This is at least that. Are we at 96% yet?
No, sir.
Let's try k equals to 5. 1 minus 1 over 5 squared. That's 1 minus 1 over 25. That's 25 over 25 minus 1 over 25. That equals 24 over 25. 24 divided by 25, that's 96. Look at that. We're at 0.9600, so this is 96. So at least 96%. When did that happen? At k equals to 5, right?
Yeah.
Now that happened at k equals to 5. What does k stand for? How many standard deviations away? How many standard deviations away?
5.
5.
5. Now they asked us here, what is the interval that should contain at least 96% of the data? So here's what I do. And I know, here's what I do. I'm gonna have 60. I'm gonna just draw some shape here. Here's 60. Here's 1 sigma. Oh man, let me go. Here's 2 sigma. Here's 3 sigma. Here's 4 sigma. Here's 5. So that's 3 sigma, 4 sigma, 5 sigma. So we have to, what's our standard deviation?
96?
No, our standard deviation, what is it?
Oh, 5.
5.
No,
Yeah.
no, look at it, it's right there. That's
21.2.
21.2. The amount of sigmas we want to go to is 5. All right? So 60 plus 21.2 is 81.2. So this here is 81.2. Okay? Plus another 21.2. And how many times do we do that? How many times do we do that?
5.
5 times.
Wait, sorry, Mr. What'd you say?
What we do is we keep on adding this standard deviation 5 times so we can get to the upper interval.
Wait, mister, what did I miss? Because my computer froze a bit.
I don't know what you missed because I don't know when the freezing started.
It started like after you were writing the numbers.
Okay, so which numbers? The percentages or when I started drawing the graph?
Before the graph.
Well, the great thing is that I'm recording this. So I'll update it I'll put it on the internet because going
Okay.
back right now is really tough for me.
Okay, thank you.
All right, so we went 5 standard deviations away from the mean, right? Now we have to do it in the opposite direction, right? We have to do it this
Yes.
way. Do the same thing. Sorry about this. This is shifting all over the place. Give it a second. So that's -1. Oh my gosh. This is not making me happy. So here's one, 2, 3, 4, 5. We have -1 sigma, -2 sigma, -3 sigma, -4 sigma, -5 sigma. And now you do it in the opposite direction. Right? 60 minus 21.2. That's 38.8. Minus 21.2. That's 17.6. Minus 21.2. That's -3.6. Minus 21.2. That's -24.8. minus 21.2. That's negative 46. So your interval is going to be from negative 46 to positive 166. You would say at least 96% of the data is within negative 46 through 166. But there was an easier way to do this. Because when you figured out that at k equals to 5, you had 96%, all you had to do was take x bar plus 5 sigma and x bar minus 5 sigma. So that would have been 60 plus 5 times 21.2 and 60 minus 5 times 21.2. And if you do that arithmetic right there, you're going to get these same answers. That was the point. The point is, okay, you figured out what k you needed to have, which was 96. All right? And then you can do what I did, or you can just use that formula, because you might have a question where k equals to 4, and you just want to find the two intervals. So if you do that math, you're going to get 166 for this one, and negative 46 to this one. You don't have to make all those other intervals because it's not necessary. That's how you would have done that question. So the key there was, number one, realizing this was Chebychev's theorem. That's not empirical rule. And two, figuring out where at least 96% was, what k it was, and then that'll allow you to get your intervals. I think it's fairly easy. There's a lot of people writing, so I'll just wait.
Oye, tú tienes la mejor clase del mundo. How's everyone doing? Oh, this is easy stuff. Let me see.
Solve it right now, Jimenez.
Let me solve it. Is negative
The answer is C.
0.6 deviation standard 166. Am I right? Jimmy, am I right?
You're correct.
Okay, he's a good man. I said, you're doing dual modality?
So, yeah, Zoom, Microsoft Whiteboard with a tablet,
Man, I love
running
it.
here to there.
You got this. Super easy, right?
Yes. Guys, you see Ms. Jimenez?
Hello?
Wait, no, you gotta go there.
We don't see her.
don't see it.
All
Where do
right,
I have to go?
look at, do you see her there?
Hello?
Yeah, now we see it.
Yeah, we see her.
Oh my goodness, you're really techy.
Yeah.
Amy, I didn't know this about you. You're the best, man. So you're good with dual modality, triple modalities?
I was frustrated a little bit.
A little, but you're better now. See, we gotta do it. You see, you know what? I'm gonna make you do
I'm in
it.
an air conditioned room.
There you go, air conditioner.
It's
I
quiet.
love, see, I love, I'm gonna tell you a story now. I love you guys.
Take care.
This is super easy. I got it wrong. I mean, right.
All right, guys. Did we finish copying? Do you guys hear me? Did you finish copying?
Yes, sir.
Mister, can you zoom out for a bit real quick?
Zoom out from,
The
oh, you
whiteboard.
want to see the rest?
Yeah.
Oh, there you go. Okay. Can you guys still see all that?
Yes.
Yes.
I'll take my tripod home. Because I have something, so usually I have a bunch of notes. I don't know if I gave it to your the stuff that you have. But for topic one, like the most interesting things that we need to remember about. Because I want to go ahead and jump to normal distribution with you. Can I move on, guys?
Yes, mister.
Okay. So I'm gonna go ahead and now I'm gonna go to the next question. By the way, guys, I am doing the assignment with you. You have absolutely no excuse if you're in today's meeting to not have the assignment. Is that true or not true?
That's true.
It's super true. So now I'm going to try and copy and paste something here for question number 3. But I am posting this on the internet, so everybody's gonna have access to it. So here's gonna be the next question. Okay, let me go ahead and spread that out if I can. Okay. So do you see that? Given a data set comprised of 2,690 measurements that is bell-shaped with a mean of 400. When you see that is bell-shaped, what rule are you using?
Imperial.
Empirical rule. It has a standard deviation. It has a standard deviation of 25. What percentage of data should lie between 400 and 475? So here's how we do this question. Let me go ahead and drag this for you guys. So that's-
Mister, do we have to write the questions too?
I mean, maybe. No, not really. It's up to you.
Okay.
Okay, so what do we do first to solve this question?
Well,
What should
first
we do?
draw the thingy. Draw
Draw
the
the thingy. Draw the bell shape. We'll go ahead and do it in a rainbow. What's my mean?
400.
What's my standard deviation?
25.
So my sigma is 25. So here at 1 sigma, what value would this be here? What value would this be here?
Wait, I forgot the percentage.
It
Would it be
doesn't
like
matter the
it was-
percentage. Don't worry about the percentage. We're gonna add 1. We're gonna 20. This didn't come up. What's
Four-
that?
425, my bad.
425. And what would the next one be?
450.
Can't do math.
And the next one after that?
475.
475. Now we can do it in the opposite direction just to practice, just to remind ourselves. This one here should be 375. 2 standard deviations
350.
away. 350. And the last one will be what?
325.
Yeah. So now what does the question ask us? It wants to know the percentage between what? 400 and 475, right? So it wants this guy all the way to here. Agreed?
Mm-hmm.
What percentage is from 400 to 425?
It was like 34.
34 for that. How about for this piece here? Next one. 13 point. Yes.
Five.
And the last one?
2.3.
2.35.
So what do we do to figure out the percentage between 400 and 475? We have to?
Just add them up.
Yes, let's add them up. 34 plus 13.5. That's 5. 4 plus 3 is 7. 3 plus 4, 3 plus 1 is 4. 47.5 plus 2.35.
Nice singing voice, mister.
Oh, thank you.
49.75. 0.85, my bad.
So what's the percent?
49.85%.
About 49.85% of the data must lie between 400 and 475. That's why we needed to memorize those percentages so that we can tackle a problem like this. But here's the thing. We figured out the percentage. We have to just remember, this is an approximation. It's not perfect, but as long as it's bell-shaped, and we should realize it's bell-shaped, approximately normal or normal.
Mister.
Yes.
So they would tell you that it's bell-shaped, or you have to figure that out yourself?
No, you gotta be told. Now, you could figure it out yourself if you had a bunch of data and you graphed it but I'm not gonna do that to you. I will tell you it's bell-shaped. If I don't tell you it's bell-shaped, you can't assume it's bell-shaped. You have to use Chebychev's theorem.
Wait, does this class have a EOC?
Is this on the EOC? We don't have to worry about the EOC.
No, do we have one
For what?
for this class? Because it's like some
No,
classes
bro,
that
you
don't
don't
have
have
an
to
EOC.
worry. No. Statistics is not touched by EOC.
Oh,
That's
okay.
blasphemy. All right, so let's do the next question. We're almost done with our assignment. Look at that. Let me just copy and paste the other question. Something weird happened here. Give me a second. Oh, I see what happened. So here's the next question, guys. I'm gonna paste it here, and I'm gonna make it a little bit wider. Gotta admit, this has come a long way. Even though I had issues this morning with getting this working like the way I want it, but that has to do with just setup. It's the technology, once it's set up, it's impressive. I don't call it, I guess it's software, whatever, it doesn't matter. So here we go, here's the next question. Let me make sure I slide it for the class that's here. Now, the only way this is working is because I have it on Ethernet. So I had to buy an Ethernet adapter for the Microsoft Circuit. I feel like I'm not paying attention to you guys, but it's because I'm there. So, sorry. And I know that some of you may be a little bit lost, but like, I'm not even sure how to proceed with that because I just want to try and get this out there.
Okay, I'm sort of lost, but I kind of know.
Okay. We'll have more practice. Let's take a look at number 4. Given a data set comprised of 2,000 measurements that is bell-shaped with a mean of 400, it has a standard deviation of 25. How many would you expect to be within 3 standard deviations away from the mean? So let's do this.
Empirical.
It is empirical rule. Now, I'm going to go ahead and draw. The mean is 400. Now, the standard deviation is 25, and it says that the measurements were 2,000, so n is 2,000. How many would you expect to be within 3 standard deviations from the mean? So how many you expect to be out here? Negative 3 sigma plus 3 sigma. What percentage would you expect first? What does the empirical rule say about 3 standard deviations away from the mean?
99.7.
Okay, I agree. We expect 99.7%. Oh, that wasn't supposed to happen. We expect 99.7%, about 99.7% to be there. But did it ask us for the percent or ask us how many?
How many?
So is that how many or is that a percent that we
That's
just
the
did?
percentage.
Percent.
So how many measurements did we make for this data set?
2000.
Okay. So 2,000, and can we multiply this by the decimal representation of 99.7? In other words, by 0.997? If you do that, if you multiply the amount of measurements that you have by the decimal percent representation of the 99.7, you're going to get approximately how many of those measurements you expect to be within 3 standard deviations away from mean. This comes out to be 1,994. So you expect 1,994 of the measurements you've taken to be within 3 standard deviations away from the mean. Now, if I ask you for the interval of this, you would be like, oh, this is 425. This is 450. This is 475. You would do in the opposite direction as well. This is 375. This is 350. Oh, wait, I should do it wider. Let me go ahead and do it wider. So this is 375. This is 350. Okay, it's a little bit too wide, but whatever. This is 325. So 325. Let me make it pretty. So 325 to 475. I mean, we answered the question here, but you would say we expect 1,994 of the 2,000 measurements to be within 3 standard deviation from the mean, which the interval will be from 475 to 325. So you expect 1,994 of the numbers to be within 325 and 475.
Wait, what?
So of the 2,000 measurements, 99.7% of those will be within 3 standard deviations from the mean. So then I just created the intervals. This was unnecessary, but I created the intervals just to go over how to create those intervals. So yes.
But to get a 1984, you multiply by 0.997, is that what you did?
Correct.
Oh,
So
okay.
68% is 0.68 as a decimal. 95%
0.95.
5, and 99.7% is 0.997.
Okay.
Yes. Yeah, you just asked me. You just asked me. I think so. Why not? Yeah, you can use the bathroom. Like, you can't use the corner. You want to go to the restroom? Please go. If they ask you for a pass, just say Mr. Costa was kind of lazy, he was lecturing, he didn't want to stop the lecture. Okay, be careful though. All right, last question. I'm gonna send a link to Ms. Jimenez on this video since she appeared. It's gonna be funny. All right, and the last question we're gonna do. I want you to try this one on your own first, give you a few minutes to work on it. So I'm not spoon feeding you everything. But would you have been able to do the assignment on your own?
To be honest, no. No,
I mean, maybe.
not for me.
Okay, so are you happy I'm going over with you?
Very.
Yes.
100%.
Okay, good.
I understand it better.
Good. That's the whole point. So does anybody have an excuse of not having the assignment by Sunday? Because I just did it with you?
No.
Okay. All right, try that problem on your own.
Mr. Acosta,
Yes?
I just came in when we were doing number 4. I was at the school. I don't know if you got my email.
Oh, yes, I did. In fact, let me mark you. I think I marked you present, but I can't remember. Honestly, let me see. Give me 1 second. And then Brendan's complaining now that he can't get in. He used the original Zoom. The first.
go here. Did you solve your problem, Andrea, in school today?
I mean, not really, but it's fine. I just gotta email my counselor and stuff.
Okay, so, all right. All right, are you guys done with number 5?
No, yeah, mister.
Do you know how to begin?
Yeah.
The first thing to do is what?
Make the bell shape graph.
Where's the mean? 400, and it's in the middle. Mean is 400.
Smack down the middle, mister.
And what do they want? What percentage they want? Between what? 450?
450 and 475.
So the first one here, 1 sigma, that would be 425. So we don't care about that one. The second one would be 2 sigma, right?
450.
That would be 450. And the 3 sigma would be,
475.
I know what you're saying. So let's just fill out the percentages for the fun of it. 34, 13.5, 2.35. And we want to know what? From between where?
450 and 475.
And what's the percentage going to be?
2.35. About.
About 2.35% of the data lies between 450 and 475.
Mister.
Yes.
You put 875. Unless that's how you rate your fours, and never mind.
Yeah, that's how I write my fours. Well, that was a quick 4. Okay. I don't know what else to tell you guys.